going to look at a way to calculate the cross product using matrices. I know many of you wouldn't have come across a matrix before, done any matrix theory, so I'll go through the basic introduction to matrices that will get you through this. We know that the cross product of two vectors A and B is the magnitude of A, magnitude of B, sine theta, where theta is the angle between A and B, times a unit vector that is perpendicular to A and B. If you can calculate quite easily the magnitude of these two vectors, and you're either given or you can easily calculate theta, and then you could work out that A, B, sine theta, then you've got to actually determine what is it, right angles to A and B. So it can be quite complicated to work it out if we don't have some other method. Now, if we've got A and B in component form, we can use matrices. Let me do a quick little intro to matrices. So a matrix is an array of numbers. Okay, an array has rows and columns. So we use capital letters for a matrix. We use square brackets, and we'll just go A, B, C and D. So that might be 3, 2, -1, 0. Okay, so an array of matrices, array of elements go to make up a matrix. This is called a square matrix because we've got 2 rows and we've got 2 columns. Now we can calculate what's called the determinant of any square matrix. Now here we've got a square matrix, it's 2 by 2 square. So the determinant of A, now rather than write determinant of A, mathematicians always like to get a shorthand way of writing things. So this, whenever we see straight lines on either side, that means the determinant of A. It's calculated in a special way. It's just a characteristic of the matrix. And we can calculate the determinant of a matrix. If it's a 2 by 2, it's pretty straightforward. We just multiply the leading diagonal elements, so that'll be A times D. And then we subtract the other diagonal when multiplied together, so minus B times C. Or probably a better way to write that, we don't write the multiplication, AD minus BC. That's pretty straightforward for a 2 by 2. So you can calculate the determinant of any square matrix. So we have a 3 by 3, a little bit more complicated. So we got A, B, C, D, E, F, G, H, I. Now the determinant of B, a little bit more involved here. We start by putting above the top row a plus, minus, plus. Always start plus, minus, plus. And we start with the plus A. So plus A we can just write as A. Now A is in the first column and takes up the first row. So when we've got A, what is left when we take out the first row and the first column? We've got E, F, H, I. So we write that down as the determinant of just like a 2 by 2 down here. So that's E, F, H, I. So the straight lines means the determinant of that. Okay, we move across the top row. So we've got plus A minus B. Now B is in the middle column, but once again it is the top row. So B will wipe out the E and the H, so we've got D, F and GI. We're moving across, so we've got plus A minus B, now plus C. Now C, I won't draw that one. It's got the first row, and the last column, so left is D, E, G, H. And we can then do our next line of calculation. So A, the determinant of this matrix, it's a 2 by 2, so we use the same rule as up here. Leading diagonal EI minus HF minus B, DI minus GF plus C, DH minus GE. So if we had values for A, B, C, D, E, F, G, H and I, we can actually substitute in all those values and we'll get just a single number as an answer. So we can calculate all that. Okay, so that's what we're going to use to calculate the cross product. So if we've got A, vector A is equal to A1I plus A2J plus A3K, and vector B is equal to B1I plus B2J plus B3K. We can use our knowledge now of matrices, all of this, to actually calculate A cross B. So A cross B equals the determinant of a matrix. We write I, J, and K as our first row, always. Then we write the first matrix on the second column over here. So it'll be A1, A2, A3, and then we write the second matrix in the third line. So we've got B1, B2, B3. Equals. How do we calculate the determinant of a 3 by 3? We'll go up there again. We've got a plus, minus, plus. What's the one we take out first is the I. I is in the first column, first row, so we've got A2, A3, B2, B3, minus J, takes out the second column, top row, so we've got A1, A3, B1, B3, plus K, and K will take out the last column and the first row, so we've got A1, A2, B1, B2. Now I, J and K are vectors. They are our unit vectors. We've then got I. Now the determinant of a 2 by 2 is the leading diagonal, so A2, A3, sorry, B3, minus B2, A3. So I've gone that diagonal multiplied together minus those two elements there, that diagonal, minus J, A1, B3, minus B1, A3, plus K, A1, B2, so multiplying the leading diagonal minus B1, A2. Given that we've got values for A1, A2, A3, B1, B2, B3, we can actually work out the cross product of A and B and get a final answer as so many I's, so many J's, so many K's. And that will give us a vector in 3D. I don't think that you need to memorise that. Well, that's pretty hard to memorise that. I think this here is what you need to memorise. So A cross B, I, J and K across the top, the components of A on the second, the components of B on the third, and then you need to know how to work out the determinant of a 3x3 matrix.